Morning children. Chapter 8 Quadrilateral exercise 8.2. Question number 6. Show that the line segments joining the midpoint of opposite sides of a quadrilateral bisect each other. So we have given a quadrilateral. No name is given. So we had given ABCD is a quadrilateral and we have taken as a midpoint a PQRS. PQRS is the midpoints of the sides. Now what is given? That the line segment joining the midpoint of opposite side. So opposite side means which one? AB and DC. Its midpoint is P and R. PR joined. Next, what is the next opposite side? BC and AD. Its midpoint is Q and S. So now we have to prove that SQ and PR bisect each other. Understood the meaning of the question? Show that the line segments joining the midpoints of opposite sides of a quadrilateral are bisect each other. What is the meaning of this one? Midpoints already given, marked here P, Q, R, S. Now opposite sides midpoint joined. Which are the opposite sides midpoint? P and R and S and Q. That means these line segments bisect each other. We have to prove. So given ABCD is a quadrilateral. To prove PR and SQ bisect each other. PR and SQ bisect each other. What we have to prove here? PR and SQ bisect each other. So what we will do here means we will join this PQ and SR. So this is the construction for us. We are joined PQ, SR and RQ. So construction, but we should write a join PQ, QR, RS, SP. This is not sufficient. We have to join any one of the diagonal. Which is that diagonal? Let us take that AC. And one of the diagonal AC we have taken. Now the proof. After joining the diagonal AC, we are getting two triangles. Which is the two triangles? DAC. Right? So we are getting the midpoint theorem here. S and R midpoint only in triangle DAC. Using midpoint theorem, what we can write? Using midpoint theorem, we can write that SR parallel to AC, SR equal to half AC. SR parallel to AC and SR equal to half AC. Equation number 1. Now which is the next triangle? BAC. Same rule using midpoint theorem. In triangle BAC, PQ parallel to AC, PQ equal to half AC. Equation number 2. Now what is using 1 and 2? We can write using 1 and 2, PQ parallel to SR and PQ equal to SR. Now how many pair we got? One pair of opposite side is equal and parallel. Therefore, PQRS is a parallelogram. Once we have proved that PQRS is a parallelogram, now you tell me what is PR and SQ for parallelogram. What is PR and SQ? PR is a diagonal, right? PQRS is a parallelogram. Then PR is a diagonal. Similarly, SQ is a diagonal. So when it is a parallelogram, what is the property for diagonal? Diagonal bisect each other. So we can write PQRS is a parallelogram. Therefore, the diagonals of PQRS bisect each other. That is, PR and SQ bisect each other. So now coming to the question, what is the question we have to prove? The midpoints joined by the opposite sides line segments. Opposite sides midpoint we have joined, that is PR and SQ bisect each other. We have to prove that we have got here, so hence proved. A quadrilateral is given, but you have to prove that the line segment joining the midpoints of opposite sides of the quadrilateral bisect each other. So what we are doing means, this opposite sides line segment, whatever we have joined, that is PR and SQ, we are showing that it is the diagonals of the parallelogram. For that we have done PQRS is a parallelogram. So diagonal AC joint by using the midpoint theorem, SR parallel to AC, PQ parallel to AC, SR equal to half AC, PQ equal to half AC. That means opposite sides of one pair is equal and parallel. So PQRS is a parallelogram. The same step we have used in many problems in exercise 8.2. So I am not repeating enough that one. PQRS is a parallelogram. Once we have proved PQRS is a parallelogram, we can see that PR and SQ be the diagonals of that parallelogram. Diagonals of the parallelogram, what is the property? Diagonals of the parallelogram bisect each other. Therefore, PR and SQ bisect each other, hence proved. ABC is a triangle, right angle, that is C. A line through midpoint M of the hypotenuse AB and parallel to BC intersects AC at D. Show that D is the midpoint of AC, AD perpendicular to AC, and CM equal to AM equal to half AB. So what is given in the question? ABC is a right angle triangle. Angle means which angle is 90 degree, angle C. So I'll write here, given in triangle ABC, angle C is equal to 90 degree. A line through the midpoint M of the hypotenuse AB. That means M is here, it's a midpoint. AM and BM are equal, right? AM and BM are equal. Now from M, a line is parallel to BC, which is that line MD parallel to BC. So here I'll write AM equal to BM. That means M is the hypotenuse midpoint. Now what is the next step point they are given? MD parallel to BC. Now show that D is the midpoint of AC. So to prove D is the midpoint of AC. Number 2. AD perpendicular to AC, or we can prove that angle D is 90 degree. Number 3, CM equal to AM equal to half AB. AM is already half AB only, right? Now we have to prove that CM. CM is also half AB. We have to join CM. Later part we will join. First we will prove the first two proofs. So we will write a proof here. Okay. M is the midpoint of AB and MD parallel to BC. So which theorem we can apply here? Converse midpoint theorem. So we can take the triangle ABC, which is the midpoint point we have to start M. M is the midpoint of AB. MD parallel to BC. The second side also we have put in the criteria. Now what is the ending point here? D. So D bisects AC implies AD equal to DC. That means D is the midpoint of AC, proved 1. Okay, now what is the reason here we should write a converse midpoint theorem. Now D is the midpoint of AC, we have got this one. If D is the midpoint, then what we can write AD equal to DC. So I'll make this as an equation number 1 also. Now the second part, we have to prove that AD perpendicular to AC. Now you tell me if MD parallel to BC is given, that is the proof part, MD parallel to BC. So angle D, that is angle ADM, equal to angle ACB. What is the reason? Corresponding angles. What is C angle? 90 degree. That means angle ADM equal to 90 degree. This shows that AD perpendicular to AC. Proved 2. So here what we should write? Corresponding angles. Now for doing the third proof, we have to join CM. So we will join CM now. Construction, join CM. We have joined CM here. Now what we have to prove? CM equal to AM. That means CM and AM are equal. We should prove. We know that already AM equal to half AB because AM is the midpoint. Now we have to prove that CM is also equal to AM. So we have joined CM. Now we are getting two triangles here. Which is that triangle? Triangle ADM and triangle CMD. Angle D is equal to angle D equal to 90 degree. Which is that criteria? We have proved in 2. Okay. Now what is this one? AD equal to DC. Where we got the first step proved in 1. See this, AD equal to DC. This is the first side we have used. Now we have told that angle D is also 90 only. So here the second side is means DM is coming. So DM equal to DM. Common. So triangle ADM is congruent to, for D it is D only, the middle letter D, right? For D it is D means for A what is the correspondence? C. So CDM. Now what is the criteria? The first side, angle and the second side. So SAS. SAS criteria. These two triangles are congruent. Now we want to know that what is AM and CM. AM equal to CM CPCT. Right? Now AM equal to CM CPCT. We know that what is AM. But AM equal to half AB. Therefore CM equal to half AB. Proved 3. So we can repeat this one because this is also one of the important sum only. In triangle ABC, angle C 90 degree, M is the midpoint, it is given, MD parallel to BC is given. So M is the midpoint, MD parallel to BC, then D is the midpoint of AC. Then AD equal to DC also we got. Now DM and BC are parallel. So angle C and angle D are equal because of the corresponding angle. So we got here angle D equal to 90 degree. Now what is the next step? We have to prove that CM and AM equal to half AB. What we have to prove? CM and AM equal to half AB. So here what is the construction we have to take? Join CM. So we are getting two triangles. Which are the two triangles we have to take? Triangle ADM and triangle CDM. In that angle D equal to angle D 90 degree. Where we have proved this one? In AD perpendicular to AC. So we have written proved in 2. Now AD equal to DC I have written, that is proved in 1 we told. What is the reason? Because in the first step we have proved that M is the midpoint, MD parallel to BC, then D is the midpoint. So that is why AD equal to DC we got. Now what is the third side? DM equal to DM common. Now we got two sides, one included angle. So triangle ADM congruent to triangle CDM, SAS criteria. Therefore AM and CM are equal by CPCT. What is AM? AM equal to half AB. So what is CM? CM equal to half AB. Thus we completed exercise 8.2. With this today's class I am winding up. Thank you.